All right, you guys are unmuted. I know.
So here's the notes. Here's number 1 because I started with number 4 and I didn't know. So I got it was advancing, and then nothing else. I didn't. Okay, so I thought it was accelerating because when I talked about it, it wasn't because it's constant. Yeah. So then the speeding up would be done as well because it's the acceleration of velocity. And 4, didn't we do that one? Okay, and then I thought that it was advancing from 0 to 2, and from then 4 to 5, but I don't know what it needs to look like.
Okay, I think we scaled these differently.
Is this 2 for you, or is this 2? What's 2? So I have it advancing from like here to here, and then
Advancing, and then retreating into the
yes, 2.
Come on, instead of. I don't know. I guess because I didn't draw that one. Acceleration, did you get something?
I don't know, is it accelerating from 3 to 5?
What is 3?
I have no idea. I mean,
Oh my goodness.
why I have this notes. So I think it's 0 to and 4 to 5 because it's accelerating is when it's increasing the velocity value. These aren't velocity parts of position. I'm struggling.
What did you get for number 4? 5. It's 5. What did you get? How did you get 3, 5 for accelerating?
Okay, so I put 3 here, and it's because the slope, it goes from negative to 0 to positive, so that's like an increase.
Oh.
The main problem with me was brackets versus parentheses, because me and Razor just screwed up a lot.
I think brackets are only for like the ends, like 0 and 5. If it's in between at a specific point, it's not really accelerating or decelerating, so they both share it. And they do parentheses. So then, okay, how did you get the speed up and slow down?
I hate those.
I am so confused because for me, acceleration, if you're accelerating, you're speeding up.
It's an increase in, I don't know, potency of the slope.
Potency of the slope.
Like, the more extreme the slope gets, either way it's speeding up. So like here it gets like, goes from a very like small slope to very big, and then from here goes from very small slope to very big. From here goes to big to small. Big to I'm not doing the corrections. I went to sleep very late. I got like 3 or 4 of them done, and I gave up and decided it's too much work because I was already tired. My 86 is good enough for me.
I've been doing mine for the past 3 days. I probably left 12 and all the bonuses for last night, which was a bad idea.
Hey, Miss Klinger. If I wanted to speak to Miss Holmes, the dean, not about this class, but about a different class, do I email her or do I just find her and then schedule a time?
You know where my office is? I think I talked to Vicky, she'll schedule you a time.
Because it turns out there's a
You know
class.
Vicky, right? China's
More, yeah. Because there was a class I had last semester that turns out has not been on any of my transcripts or anything whatsoever.
What class?
Biology 111.
Seems like I took the class. See my notes.
Yeah, I'll definitely get that worked out.
I put 3.5 instead of 4. I think I was getting a little too specific with everything on my grades.
I know at least one of my scales is pretty off on one of them because me and Rezo were considering the middle point between 1 and 5 to be 3 and not 2.5 or whatever
This
it was.
one?
Yeah.
Yeah, me too.
That's whatever.
What's your student ID?
What do you mean by student ID?
My college
Like
ID.
my email?
No. You know
Because I
how-
don't actually have a student ID. I've never got one.
Yes,
You have
you
one.
have one. You know how the last 4 digits, the 4 numbers at the end of your email? That's
the
part of your
last
student
one.
ID.
I think for us, the first digits
Oh,
are
I
like
understand.
8, 7.
Reed does that all
And
the
then
time.
Well, 11 shows up on your
Why is
transcript.
Miss Klinger in the back? That's what I'm.
I'm looking at your transcript right now.
Whose transcript?
Mason's.
Why?
Who's Mason?
Wait, my test.
Did you do that?
Yeah.
Did you?
What is that?
I don't know.
That's all this.
I finally got copyright permission for my pictures.
In third year, 10.
My mom sent, she sent me the snapshot of her conversation with the guy, just so I would have proof.
Are these a Delta T now? So you cancel the numerator and denominator, not regular Delta T out, so I.
Okay, here, I have 2 questions for you on your homework.
General side.
Go ask me,
Yeah.
Give Sammy your answers for the
For the what?
that. Read it homework.
Yeah.
I haven't done that one.
I think I'm really confused on one of it, but you know
Especially
what?
the velocity graphs.
Yeah. Philosophy.
Philosophy?
You know.
Wait, so are you taking?
I know. You should be
I'm
taking
going to be
public
signed up
speaking.
for public
No, I
speaking
watched it
art.
at home.
What?
Oh
I was
shit.
gonna show Count with something.
Oh, I thought it was this thingy, and I was about to freak out.
Hey, Rezo.
No, I would have cried if
Why
I
did
got
you
that
get
at
this?
Because I'm a fool. For what?
This one, you got that it doesn't accelerate, but isn't this because it's negative? It would just be going backwards, but
Well, you want
you
to
have
talk?
to
You
take the
want to know
absolute
something,
value.
Sammy? You want to know something?
What?
Acceleration is the double prime of s of t. So this is the prime of s of t. If we're gonna go another prime,
It's just a straight line.
it's a but in the negative because the slope of this is negative. So it's always gonna
So
be a
it's
negative
down
acceleration.
here.
Always, always.
I don't know if
It's always gonna be.
But I
negative
thought when you're
acceleration.
doing velocity, the negative versus positive was the direction. So if you're talking backwards, it would then
But
be
yeah, I should
absolute
just sign
value.
up for public speaking art and music.
At this point, is the slope gonna be negative?
And it was beautiful.
At this point, is the slope gonna be
And I
negative?
didn't want to wake up.
At this point, is the
Well,
slope gonna be negative?
Mason!
It's just one straight line.
I even
But
drew
you're
a
going
picture
backwards.
last night.
It does not matter. It's a derivative.
It's right there.
Okay, where do you
I
put
wanna
these
color
things, Miss Klinger?
It's pretty cool.
You did more.
I wanted to draw
just
actual
did
Rick, but I couldn't get his head shape right.
Have you thought about adding
And it's just,
You guys need a paper
like
clip with
little?
I have a little
flippy
doily. I feel like, you know how there was those like Franciscan
Oh,
monks that
like
had to copy everything back?
Yeah.
oh, I put it here.
Look at them
So we're
now.
drawing out my pictures. Okay.
I
I don't know what it's called.
really weird Franciscan monk.
Did you even study for the
I
test?
made a study sheet.
Yeah, he did. It's
Did
pretty
not
helpful.
Use it.
I used it. Thanks, Mason.
But I'm just making it.
Wait, what is that?
This is the test correction.
Oh, okay.
You just want
Oh,
that to credit, right? No.
Do you want the
Rezo,
original?
wait.
No, he has the original.
Wait, Rizzo, this is your stuff. Here you go.
Why is it?
Here are a whole bunch of paper clips. or
Sammy, you gotta come here.
whatever they're called.
Papa Clips. Papa Clips. Papa John's. You know my mom calls
Rizzo, what are you?
my mom calls.
Now.
She calls it Papa's job.
Wait, do you guys want the corrections?
What did you do for it?
I just BS something and I'm probably not gonna get full credit.
The horizontal one? Yeah.
What did you do?
I did like
Oh,
nothing.
don't worry, this is like my answer.
That's exactly what he did for us in class, though.
Wait, okay. See, I did what he did for us, and then I
This is why I didn't watch
That's what I
that.
did.
Yes.
Here, look.
You guys have 1 minute
This is
to.
all I did, and I have no idea what I actually said.
No,
didn't
huh?
Chloe.
No, he did part of it for us in
Wait,
class.
so what about our
I
grading?
did this, but where does that go?
I think we're gonna go over
That
that in
means,
class
I don't know
first.
how we got to that.
Alright, so test corrections here.
No one else is trying to.
What'd you say?
No one else is
Other
turning the
stuff
lab.
here.
I turned in the lab. Online.
What lab?
Online.
Oh, no, this is my test. Oh, my actual test.
Yeah, do you want to make Miss Cleaner suffer by unstating everything?
Yeah.
Yeah. I swear, if there were like 12 Herculean trials, like one of them would be removing staples. It's never too early for comedy. I watched Seinfeld this morning.
You always watch that.
I do.
I probably got that one wrong.
I just heard about this.
You know what, Sammy? If you think you're right, it's not gonna change anything, but it'll make you feel better.
No, it won't, because if you get it wrong.
Are we turning in?
Never mind. Expect it to do mad, and then you'll be happy.
Once we reference.
Let me ask.
Yeah.
Okay.
Don't you mean door?
Door.
Are you taking up the homework right now, Dale?
I'm sorry.
Are you taking up the homework right now?
I was going. What I was going to do is collect the test corrections first. Then I was going to give them a few minutes to collaborate on the minutes, make sure they're happy.
Okay. So you get a few minutes to collaborate, Chloe.
Because my battery gets full and I actually determines the battery life if you keep on charging.
Mine doesn't. I've been doing that for 2 years.
But test corrections are
It makes
due
your
now.
battery last over time.
Corrections are
Give me a stack.
Yeah, test corrections due now.
So I can get a stack.
I'll take the follow-up in a few minutes.
I don't think he wants
I told my parents that
What'd
what's
you
the
guys
model
do?
of your phone?
1 plus 3.
Text it to me so I can look it up later.
say have a few minutes. Collaborate on the homework.
this random bigger sheet.
Oh, at least can I have a big clip after?
I'm just gonna put
Oh, I'm sorry.
For a few minutes of collaboration.
Okay.
Amanda,
Yeah?
Yes.
one more thing. On the question here was, when I collect the homework, am I collecting just the lab follow-up or that and the extra problem? And my intention was only to collect the lab follow-up and then talk about the other homework problem that we went over in class yesterday as separate. So, but did y'all hear that? Understand?
Yeah, I heard it.
So we're collecting the lab follow-up and we'll talk about the question.
Yeah.
Yeah.
I
I
got
got one question on the board. We'll talk about that. Yeah, question. Okay, so
What other
we'll give you
The homework?
Yeah.
a,
Took off that page.
just a few minutes, just a handful of minutes to collaborate on it.
Handful minutes to collaborate on what?
To collaborate on the lab.
Have we not done it
Okay,
yet?
Brittany, Patel.
Yeah.
I don't know. I don't know if he's just
Why
not
do
talking
you,
us loud.
what do you have for
You should ask
accelerating
her,
and
say
decelerating,
something
and why
about
you
it.
have it to-
Parentheses 2.
Dale, the sound seems to be really weird today.
Okay?
So,
Is it-
explain 12.
Okay.
I'm not sure what's going on.
Your sound, is it better now?
Just get out.
You think it's better?
Here.
I want to join.
Yeah. It's kind of going in and out. I don't know what the deal is.
SFT graph. This is an S prop. It's
Yeah. We're gonna reboot our sound real quick while we got just a few minutes here. So,
Okay.
The connection should stay, but. Oh, this is sound.
Ratings. This is where we have to make estimations of what the slope is on the S prime of t graph. So here it's positive.
He said
Here it's
it was
zero,
good.
Here it's negative.
So they're gonna
Here it's
reboot
zero,
their sound.
Positive, and here it's kind of less negative.
Voice
That's
get
what
deeper?
it sounds like.
Because his voice is like some days is deeper
So-
than others.
Yeah, it
Or it
sounds
might
like
just
he
be like
has
a
a
morning
cold.
thing.
We're saying at 1 and 3, it's not accelerating because the slope is 0, correct?
1 and 2.
I think.
Does anybody else
See,
have
the
test
thing is, it's not
fractions?
really.
Do you have test
It's important to
fractions
know the
for
points
us?
where it's not doing anything in acceleration, but that's
Amanda,
it's like for those little.
Yes.
is it better now or not?
It's,
It is better.
Well, good.
You
Yay!
guys
Yeah.
are getting a lapel mic.
Well,
I'll be right back.
It's
Fast.
we're beyond that.
Trying to sound it. I have like clairvoyant communication. Okay, anyway, back to it. So yeah, you gotta imagine
So
a
you're just
slope.
finding the slope at different points.
Do we need another?
Yeah, so what you can see here is that it goes from 5 to -5 here. Right?
Oh, it's not gonna start.
And so that's decelerating. And down to here, -5 to 0, it's increasing, so that's accelerating. And it actually increases from -5 to 5. And then here it decelerates. But
But
I
wait,
don't exactly know it. Actually, this is accelerating, but it's just accelerating less.
wouldn't it be accelerating from here all the way down?
Yeah, because
No, because it would slow down to.
It speeds up for here. And it slows down for here.
But you're continuing
wait,
to go
wait.
closer to 0.
Wait, I'm getting distracted here. Just look at this interval.
But
I don't
understand that.
I don't know why you have that as the interval.
You just need to get in the habit of drawing the tangent lines. They just
I
explain
don't
everything.
understand tangent lines. What in the world are tangent lines?
Do you remember in 8th grade, Sammy, when we drew circles and then we drew a
Yes.
line that touched one point?
I know what it looks like on a circle, but I don't understand where the tangent lines would
Well,
come
just
into
imagine
play.
it.
Okay.
Pick a point. And then
There's a tangent line.
And what's the slope of that line?
There's a tangent line.
Yeah. Now just imagine it, but not on a circle. I mean, it's
I
just
don't
helpful.
think-
It's extremely helpful to draw the tangent lines, to have a taste of the derivative. I don't know. What is that even supposed to mean?
So how do you use those tangent lines? to
That's the
solve-
slope.
That's the slope?
The thing is, at this point, the slope here,
It's steep.
no, at this crest right here, the slope here is 0.
Yeah.
So on the acceleration graph, that's going to be a 0.
No.
Right, just imagine
Except for this.
what the acceleration graph is at some point.
I don't think so.
Yeah, the thing that really screwed me over was the rectilinear graph, but you know what?
I think we all got the same rectangle here.
Yeah, it is, but on number 12, it was really annoying.
I think we all got the same one. Oh.
Yeah.
How did you get the arrows like that?
Do we have to put the arrows?
Yeah,
You
they
didn't put the arrows in class.
Well, it's very helpful to describe things that don't have a constant rate of change. I don't know. I just do it for a utilitarian purpose. Oh, not anymore. Is it okay if I add it?
Not right now.
Okay, I'll do it later. Well, you guys are just looking at my answers right now, so I'm kind of just standing around. Yeah,
Good
I
on
tried.
this, Carson?
I think if I explain it
Do you need
more,
to
I'm going to
pull
confuse
it?
you guys more. You guys just got to get the tangent lines of
You're
what
good?
the acceleration graph means.
You're good?
You know, I'm expecting a mediocre grade on it.
Ready for December.
I'm expecting not an F.
I'm ready to
The
know
end of the
from
semester.
colleges.
Yeah.
How do you wear sweaters on days like this? I mean, I know it's like cool in the morning, but you know it gets like to 90 degrees.
Except for.
Oh wait, you're wearing a shirt under.
Yeah.
I think because it's crime
Wait, so
of
we
tea
have, like, the
that makes it
steepest
advancing.
How'd it go?
Something
My dad's
about that
really
logic
into
is what we came up with.
Alright. You should like.
You guys ready?
Do you want it to look like the original sheet too, or?
Money? Sheet.
Yeah, I guess if you have something on it. Can I have? Make sure your name's on all the sheets, please.
I tried.
So make sure your name's on sheets, please. Now, y'all are fine, but still, they have to scan individual sheets. Close yours to state the law.
Actually, let me make sure. Sorry. Yeah, I'll just deal with it. The real question is why did you have a derivative function in the calculator? Oh my gosh, I hate to. It's 3.
Do I have yours there?
Why?
Yes.
Why?
These are that's not.
Did you not pay attention in
Hey.
class? Gosh.
Alright, I think I have
You
everyone.
guys make fun of me for not paying attention in class, but I actually get these homeworks done. Yeah, it pisses me off, dude.
Let's move on. Yeah, you'll have to bear with me. My voice is not strong today. We all have the labs turned in and credits. So now we'll start with the problem that the additional problem that I gave you in terms of the analyzing the vector motion alpha also here. On our upcoming test next Thursday, which is coming up a week from today, we have a test on this block of materials. You will need to be able to do both practical look at velocity and acceleration like you just did, as well as the algebraic like we did yesterday, and we're going to talk about things. Everyone will know. Okay? So, what questions did you have on that problem from yesterday? I don't even know what it was. What are you doing wrong? I don't have the answers. I'm not working it out, so we can share and see if we have a. What was remind me what the function? Remind me what the function.
Did you complete all of these?
Yeah, look, answer 7. I just crammed.
Let's see.
Oh yeah, that's what I was saying in the morning. Yellow and green.
Okay, so let's just go down the list of check answers. We'll come to a consensus again. I have not worked it out, so I don't know what the answers are supposed to be, but I'm going to assume y'all were able to figure that out.
Mm-hmm.
Function. What was the first question?
That's this
Let's come to a consensus on that.
Having trouble with this one, actually.
How do you calculate net displacement?
S of 5 minus S of 0.
equals 15.
5 minus S of 0. And what number did we get?
15.
15 minus 0, which just yields 15.
Wow.
Oh, dang it.
That should be in linear units, so I didn't even specify it could be feet, it could be meters. For the sake of argument, let's just call it feet.
Feet? Oh my gosh, I said units throughout my entire
If you put units, that's fine. You got it correct. Because I didn't specify what the unit was. If you left off any kind of unit measurement, then that would not be correct. Are we clear on that?
Yeah, my chemistry teacher would freak out if we send them.
It's not units squared, it's units. Okay, what's the next question you're asking?
Velocity.
Find velocity. Do we need to go through that? Let's just see if everybody got the. So we first had to find the velocity function, and we went through that. How you do that yesterday. Let's see. Tell me what you think the velocity function is on what we did, and then we'll. Okay, what'd you get?
3t squared
Nice.
minus 10t.
Plus 3. Okay. Anybody else get that same function for velocity? Okay, you got several agreeing, so I'm going to agree that looks reasonable to me. Everybody else get that or not? No? We didn't do that.
I got him, coach.
So I want to go through that process, or do we feel like we can do that? Kind of?
Yeah.
Okay, we'll do it one time real quick. Okay, V of over here. V of t was defined as limit delta t goes to 0 of delta s over delta t.
Mm-hmm.
And we calculated that as limit delta t goes to 0 of S of T plus delta T minus S of T over delta T minus T. So again, this is just showing me the change, the difference in two S values and the change or the difference between two T values. So delta S over delta T. That's as simple as you can make that. The rest of it is just algebra. So I have two different T values and two different S values. And so what is S of T plus delta T equal to?
T plus delta T cubed. Oh my gosh, it's gonna take a while. Minus 5T plus delta T squared plus 3T plus delta T. I can't stand how plus looks so much like T. I lost my mind on the homework.
Yeah, that kind of bothers me. That's one reason you'll notice when I write my T, I put a curl on the bottom to try to make it look different than a plus sign. Although on the board, sometimes getting in a hurry, my T's and pluses start to look a lot alike.
Well, let's try the mine.
Sometimes my T's look like E's when I get real fast. Then we've got the minus S T, which that is S. That's just T cubed minus 5T squared plus 3T. This difference is just delta T.
Wonderful. One of those parentheses is the other.
Then the rest is algebra and then applying the continuity theorem to evaluate the other. So the hard part is just doing the distributive problem. So this comes out to be T cubed plus square delta T plus 3 delta T squared plus a delta T cubed minus 5T squared minus a 10T delta T minus a 5 delta T plus a 3T plus a 3 delta T minus a T cubed plus a 5T squared minus over, oops, and that's what it is, just, oops, got one thing. And then you got like T cubed here, and then you got a minus T cubed there, and minus 5T squared, and a plus 5T squared. And you got a 3T cancels. Realize what you did wrong. Okay. So from there, you can finish. At this stage, what you'll see is every term now has a delta T in it. Every single term has a delta T in it. So you can factor delta T cancel. We did determinacies now. Come on, you can apply the continuity theorem and get an answer. From there, it's not too big. Okay, so there's my velocity function. That's not the only thing. Question? Raise another question.
This is just a little concerning to me on the test because you had like a ton of space on a whiteboard.
So like I need to leave lots of paper on the test for you.
Yeah, it'd be nice to have room.
And I'll try to remember. Maybe I'll put one problem per sheet, so you can have a whole sheet to do one problem.
That'd be nice.
That's a good suggestion. I'll try to keep that in mind as I lay out the test. Get plenty of space to do all that work. Okay, good suggestion. So how do we finish problem 2 though? I don't think that's all it said. What else did it say?
We have to find
0. So we got to set this equal to 0. What are we we doing when we do that? Why do we do that? It says do it, but why? I said so. Why are we setting the velocity function equal to 0 and solve?
Because it helps us with number 3.
Critical values.
Because it helps us with
number 3. Why is it important in number 3?
I don't know, because like, actually, is someone else answering it? Yeah.
That's when velocity change. When velocity is 0, that's when you're changing between positive and negative velocity, and positive and negative velocity is what determines advance and retreat by definition. So it's important to know when it's 0 so that we can figure out when it's positive and negative. When is it 0? I need to do that work too. Do the quadratic formula factor. It does a factor. I got factor. 3t
minus 1.
Lots of ways to do it.
Oh.
So let's see what's that. Minus 3 and minus 1.
I got that.
Equals 0. So this tells me that t is 1/3 or 2. Or the quadratic form, whatever. Okay, good. So what does that mean? I found these numbers are called first order. Good. Why do you think we named it that? Any ideas why we might name it first order critical?
Because there's a second order.
First order means we're dealing with the first derivative, not the second derivative.
Yeah.
The critical is because, like we just said, what happens at these t values? Velocity changes from positive to negative. That's a critical piece of information. So the name is important too. Okay, what's the next problem we got there now? Now the critical values. Intervals of increasing and decreasing, right?
Advancing and...
Oops. I just said increasing and decreasing. You think those are related to advancing and retreating?
Well, I mean, the numbers.
Increasing, we're going to do this in just a moment. The next little step we're going to take, we're going to generalize what we've been doing from motion involving physical motion and position and velocity to a generic function that can be applied to anything like money or production or whatever. It doesn't have to be motion. And the idea of an increasing function would be advancing in a position idea, and decreasing function would be retreating. So those terminologies you've heard before are related to the concept of advancing. So that's going to come next. So I used the word that we've used before, we're going to use again. But now we're talking motion, so we're talking about advancing and retreating.
Okay.
We do number 3, find subintervals advancing and retreating. So what did you decide there? How did you decide that? So, you didn't get velocity, so you couldn't finish the problem. Because you got the velocity function, you should have been able to finish the problem. So, when is it advancing and when is it retreating?
I'll go for it. Or should I just say it? Should I just say it?
Ezra, go ahead. You have your hand up. Thank you. What do you got?
Okay, for advancing, I got bracket 0, 1 comma 1/3, parentheses, union, parentheses, 3 comma 5 bracket.
Good. When is it retreating? So how can you decide that? How do you know that? David said, I took out my calculator. That's a good idea. What did you do with your calculator?
You did it with this calculator? Oh.
The graph. graph this function. Oops. I get the picture without even having to do the whole graph. How so? Well, it crosses the axis at 133. Crosses the axis at 1/3 at 3. From pre-calculus, not calculus, what do you know about a function that's quadratic with a leading coefficient of positive 3?
What are you saying? What are you saying?
Well, if it's quadratic, what do you know about a quadratic function in general? Pre-calculus.
It opens up.
Travel, right? It's either this way or it's this way.
Mr. Krabs. That's
It
Right,
opens
is.
up.
Opens up because why?
because it's positive. Wow.
That means it's got to be this way, and I didn't need a calculator for that. It's okay to use a calculator. I'm just saying I knew that just because I remember my pre-calculus.
Yeah.
Okay, so that tells me where it's positive and where it's negative. That tells me where it's advancing and where it's retreating. Are we clear on that now?
Mm-hmm.
This was the velocity picture.
Lovely.
Okay, good. Next up. Total distance traveled. How do we do that?
Gotta use some absolute value.
And we gotta get involved with distance, net displacement in each of those subintervals. We want to do absolute value, make them always positive, so we get the total walking distance. So total, this is whatever. Total distance is going to be, since we've got 3 subintervals, we got to have 3 over here, and we add up 3 pieces of walk. Tell me, I'm going forward for a little bit, and I'm going backward a little bit, and I'm going forward. Advancing, retreating, advancing. So I've got 3 sections I've got to do. I've got 0 to 1/3, so S of 1/3 minus S of 0. What's inside this absolute value? This is just net on that one interval. The absolute value makes it positive, which guarantees I'm just counting total distance rather than net displacement. Net displacement can be negative, but I don't want that for total distance. So then I do the next interval. You can do them in any order, but I'm going to do them in numeric order. So I'm going to do 3 1/3, and then I'll do the last interval. So I'm just finding net displacement of each interval, but making it positive and then adding it up to get a total distance, whatever that comes up to. What's that? What's the final answer? Let's get a consensus on that. 33.96. 33, is that like exact, or was that a round off? And that was exact. So you got to plug a 1/3 in here, so you got to cube it. So that's probably going to be 0.481. That's what I got. Let's just say that's round. I don't think that's exact. Y'all understand the difference? Let's review that one time. What's the difference between exact and approximate? That comes up on tests all the time. Approximate happens anytime you start writing down decimals generally. Now, if 1/2 is exactly equal to 0.5, I grant you. But 1/3 is not equal to 0.3. It's not equal to 0.33. It's approximately 0.3. So anytime you, generally, most of the time when you plot your calculator, you're giving me an approximate answer, unless you keep it in exact symbols like pi or square root of 2 or 40/3 is exact. Once you give a decimal, it's approximate, other than a few special fractions that have terminating decimals. Okay. Number 5, A of t. So we need to set A to 0. So let's get a consensus. What, I don't want to have to go through that whole limit thing, man, but what, those who got A of t, what did you get as your velocity functions? By the way, did anybody else get that number that Jacob gave me this number and I wrote it down and no one disagreed, so I'm going to assume it's right. Did anybody get a different number for the total distance?
I think I just got it wrong.
Oh. How do you think you got it wrong because that's the number I wrote down, or because, I mean, I don't know, I've not calculated. I just wrote down what Jacob did. I'm not saying it's wrong or right. I don't know, honestly. I haven't worked it out.
Oh, is that S of, what's that?
Everybody else worked it out and see if you get it.
So there has to be 3 of them because the roots.
Make sure we're all getting the same answers.
Okay.
Yeah, it has to be 3.
What's that first one that says net? Is that S of what?
No,
That's
it's
like
S
1/3.
of 1/3.
S of
Minus
1/3.
S of
Minus
0
S of 0.
plus
I thought that was like some
3.
kind of Norse rune or something. I couldn't read it.
You just calculate on this.
Oh, you want the acceleration thingy?
Yeah, we're gonna. I'm still wanting to get a verification on this number of total distance. I only got one person give me a number, and no one seconded it. No one's giving me any indication that that's accurate.
So didn't do it right.
Okay, well.
I forgot to bring a calculator today. I learned how to use a calculator. It's like graduated college and engineering work. It happened when I was in college. We had a slide rule. My first class in college was learning how to use a slide rule.
Never under the pressure of doing pivot tables being.
We have trick values with the mantissa and the characters.
Wait, so how are all? How does it get so big? That's my question. If you're dealing with numbers like 15 and stuff, how does it get so huge?
Because you're going up and down. It's the total distance.
Crap. So cool.
Everton, did anybody there get a calculation on this?
Is
No,
that
just wait.
33,000?
33 points.
Okay, point. That's understandable now. I was so confused. I'm gonna use this calculator.
I realize that you can plug in this function into your calculator and the y equals, and then use that to evaluate these points rather than typing out this computation every single time.
You are right.
Y'all done that? Y'all know what I mean? Davidson, you familiar with that? Anybody there? What I'm talking about?
I'm sorry.
So, I thought it wasn't Monday any longer. I got nothing here, folks. How deep? I need my glasses. I don't do work. I can't believe y'all making me do work. This y'all doing this stuff. Okay, so can you show something?
Just dumb.
So if I go into my y equals, I can type that function in. What is the function? Like x raised to the third power minus I x raised to the second power plus 3. Okay. And let's see, what can I do with it? Well, there's a couple different ways, I guess. One way is you trace it, I guess.
Yeah, I still didn't get it. 28 now.
They, assume standard.
I don't know how you got this.
I can trace it, and I can go to, well, we know what S of 0 is. The 0, I can go to 1/3, so this is 1, 25, 3. Great. Okay, that's a round off. I had to write that number down.
0 for a lot of them.
Um,
Are we plugging it into
I can continue to trace, and I can go over to 3, so I can put 3
the
in.
second one, the velocity? Oh, this makes no sense.
Probably negative 9, looks like.
Because at 1/3 it's 0.
But 5 now.
Plug it into the original.
Tells me the answer is 15.
Okay, plug into original.
I got all my numbers, and I can add, subtract as specified up here. Another way you can do it is from the home screen. We do, so if I go to variables, what variables on this account? Oh, right there, right in front of my face. Okay, so I can go to y bars, and I can pick function, and I can pick y1, and I think I can put my parentheses and put 1 divided by 3, close parentheses. I think that works. Oh yeah, look at that. I can actually evaluate this like you do it.
How do you do that?
The bars button. You plug in the
I
bars.
did, I wanted to change it. I can just now hit second enter and go in and change that to like just make it a 5. I get my 5. There's a lot of ways you can use your calculator. Or if you want, you can just type out that computation every single time. Okay, so do anybody get a number, or we can either verify this or contravene this number that Jake taught the course almost 10 minutes ago?
I got this. That's what I got. I got about 33.962.
Fantastic. So Jacob, you've been vindicated. Well, I am sorry I doubted you. Let's go on to another problem. What's the next problem?
Acceleration.
Acceleration.
Acceleration. So I need the acceleration function. That's where we stop. Acceleration function. Let's get a consensus on what that should look like.
Is it?
If I do that work, Maddie, what do you have? It's t minus 10.
10. You know that? Oh no.
How beautiful to me. Anybody else get that?
I got that.
That's okay, good. Sounds good. We've got several seconds and thirds on that, so it's got to be good, I believe. So we got to set that equal to 0. Why do we do that again?
To find the second order critical values where acceleration is positive and negative. I mean,
Exactly.
basically.
Good. So this means t is equal to, what is that, 10/6, which is 5/3. So that's our second order critical value right there. There's only one. And as Rezo said, that would be where acceleration is 0, and we can decide on either side of that whether it's positive or negative. So that would be the next thing. I think is problem 6 is we have to decide when is it accelerating. Once again, a simple graph will tell you that. What's the graph of that function look like?
It's a linear graph.
Yeah, with an intercept of -10 and a slope of +6, so it's got to do something like that. And I know at this point, because I just figured it out, it's 5/3. I know what the whole thing looks like.
Yep.
I didn't put a scale on there because I don't really care what the scale is. I just need to know where it's positive and negative. That's the whole thing I got to work on. So it looks like it's accelerating when? thirds to 5, decelerating on 0 to 5. Good. Almost done. It seems like there's one more thing. You got to put it all together and decide when it's speeding up and slowing down. When is it speeding up? When is it slowing down? Speed up. Slow down. Now it gets a little bit dicey. It might be beneficial, in my mind at least, to help you see it. I'm going to draw a diagram. I didn't do this yesterday because acceleration was always positive yesterday. This time, acceleration is changing. So I'm going to draw a little diagram to help me see this better. So I'm just going to do a number line from 0 to 5. And then I'm going to mark my important information, like 1/3 and 3. So looks like 1/3 is about there, and maybe 3 is approximately there. And we learned that the velocity is positive here and here, so this is velocity. Negative in there. Then I guess I'll mark my critical value for 5/3 on there. Where's 5/3? It's almost 2, so maybe right in there. So what I need to do is indicate that how that works. We know that to the left of that red mark, acceleration is negative, and to the right is positive. So I'm going to kind of think of this as distinct regions. I got a region here, here, here.
What's that midpoint supposed to be?
So let's see. My velocity is negative in this region, even though it's split up by the red mark, but that's still negative. And then the acceleration is negative to the left of the red mark, positive to the right of it. So from there now you can easily determine speed up and slow down.
Yeah.
Product of these two, let's put the product down. That helps too. So what's the product of those two signs? Velocity times acceleration. Negative. That one's positive. This one's negative. That one's positive. So now I can get my speed up and slow down fairly. Looks like negative means slow down. So that's from 0 to 1/3. And then also slowing down from, oops, that number right there was 5/3. So 5/3 to 3. And then speeding up on 1/3, 5/3, and move on. Okay, we got that now? You don't have to draw that chart. If you can look at these two sets of numbers and figure it out, that's great. That, for me, it helps kind of organize my thinking about velocity being positive and negative, acceleration being positive and negative, how those two things play together to affect the motion of the particle. Question raised.
Yeah, I would normally just graph both the velocity and the acceleration, and I see like where they're positive and negative.
Exactly. That's effectively what this is doing, is putting both those on the same set of axes. If I take this graph and this graph and put them together on one graph, you'll see the same type of pattern. So, yeah, absolutely. That's perfect. This is a quick handy way also in case you don't have a graphing calculator. Yeah, that works good.
Great.
Okay. Any last questions on that? How many got all of that correct? All the way through?
Almost, but not quite.
The one with it all the way through, yay. How close was almost but not quite?
Not 4.
Again?
Not 4, but everything else.
Okay, but everything else. Okay. Now you understand number 4. What about everyone else who got not quite almost, or less than almost? Everybody else follow it better now? Okay. Well, next up is, I promised to find the over problem 1 in the section 2 form. So let's go with that for a minute, make sure we're clear. I realize the book gives you the true and false in the back, but let's make sure we're clear on understanding why it's the true and false. Clear on the concepts. Okay, so let's start with a volunteer to take on 1A. Razor has his hand up first. Thank you. Go.
Alright, 1A, true or false, the slope of the tangent line to a function f at the point x equals 4 is given by f prime of 4. And I put that's true because what a derivative graph is basically just a graph of the slopes of the function it's derivative of.
Yes, it's giving you the tangential slopes. The derivative function is giving you the tangential slopes. Like we discussed earlier with velocity and position, you can have average velocity between 2 distinct points, but the tangential point, we got one point only, that tangential, that is considered the instantaneous velocity. And so that's, that tangential slope is the instantaneous velocity. So that is exactly right. B, I'll tell the B. That's basic.
Okay, true or false, the instantaneous rate of change of a function f at the point x equals -3 is given by the formula f prime of -3. And I said this is true. It matches the definition of instantaneous rate of change on page 159, where it basically is just the derivative function, or f prime.
Absolutely. Excellent. And again, like I was just discussing, tying in the idea of slope of the tangent line to what's called instantaneous rate of change. Those two things go together. Excellent. Let's see. Out here. Joe wants small tech, no.
The instantaneous rate of change of the function f at x to the equilibrium.
Not false, right? I mean, once again, the tangent line is the instantaneous rate of change. The secant line is not. What we did is we looked at secant lines and getting them the width shrunk down and eventually becomes a tangent. But any one of those secant lines is not the tangent. It's the limiting process that causes that to happen. Okay, how about D? Josh, take D for please.
Yeah. It reads, where a function f is positive, its associated slope function f prime is increasing. And I got that as false because it wouldn't necessarily be increasing, but it would be above the x-axis.
That's exactly right. Whether the function itself is positive or negative has no bearing on the slope. That is exactly correct. E. On E. A volunteer. Picking on people. Who's that new student sitting in the very back by the window back there?
That's Miss Klinger.
Klinger, you're up. No, I'm just kidding.
Miss Klinger.
Chloe, would you
Seriously,
take-
you want me to?
if you want, I was just kidding. If you want to participate, go right ahead. I was
No,
on the fire.
I'm good.
You're gonna hand it to Chloe.
Yeah, I'll leave it off.
All right, thanks. True or false, where a function f is decreasing, the associated slope function f prime is negative. And I got this was true. On page 156, it says that where f is decreasing, then f prime is below the x-axis, and that means that it's negative.
Exactly. Okay. Good. Good. And again, absolutely. And tying into what we just saw here, when the derivative function was below the axis, that meant we had a negative velocity, which meant we were retreating, and that whole concept of retreating is like a decreasing function in general period. Okay, 1F. What else? Justin.
True or false? F has a steep slope. Graph. Instantaneous.
That's a hard word.
Yeah, I know. Graph change. At that point, we'll have a large magnitude. I put through.
It's large magnitude, meaning it could be positive or negative. So it could be steeply up or steeply down. That would be a negative. But the magnitude of absolute value is large. Okay, G. Sammy, could you take G for us, please?
Yes. True or false? When the graph of a function f is decreasing with a steep slope, the graph of the associated slope function f prime is negative with a large magnitude. I put that it's true for basically the same reason we said in f, except this time it's a negative slope instead of a positive slope.
Got it.
Yes. They specified a negative slope, so it will be a negative number, large magnitude. I agree with that. H. Brittany, can you finish this out, please?
Yeah. True or false, suppose an object is moving in a straight path with a position function s of t. If s of t is positive and decreasing, then the velocity v of t is negative. And I said true because of the relationships between the derivative graphs and their original graphs.
And I would ask one question real quick to everyone. Does it matter that S of t is positive in that statement?
No.
In other words, if I change it to be, if S of t is negative and decreasing, plus v of t is negative, would that change the truthiness of that statement? Not at all. Once again, the actual position of the point that's moving does not matter in terms of whether it's moving forward or backwards. Okay? Good. Any questions on the homework in section 2.1? I have put several problems there for you to try out. I wasn't reflective again. This is practice. But any questions on those problems?
I'll just ask a question. Mr. Gaddis.
In particular, yes, Reza.
Do you, on the first couple of questions, like 21 through 24, could you just do one of them to show us how you'd go about it?
23.
Yeah, can you do 23?
I
just want to see your approach.
We'll do it. She seems to be focused on this board, so I'll stay here. Our camera operator had to step out, so I'm going to stay on this board. Is it focused enough that you can see this board here?
If you don't write finely, I can see it.
Okay, I'll try to remember to write really big.
Yeah.
Okay, so our criteria, I'm going to start on this board here. Our criteria given on 23 are F of -1 equals 2. Prime of -1 equals 3. F of 1 equals -2, and F prime of 1 equals 3. And it says to sketch the graph of the function f that has the characteristics. So I'm not sketching the graph of the derivative function, I'm sketching the graph of the original function. So what I would start with is locating the known points I have on the graph. So this is a known point here, so I'll plot that. Let's say that's -1 and positive. And then I have another known point at 1, -2, so 1, -2. So whatever else I do with my graph, it has to hit those 2 points. The rest of it has to do with slopes of tangent lines. This tells me at that point I have to have a slope of 3. Slope of 3 is pretty steep. So I'm going to put just kind of a short segment here that's pretty steep going through that point. I'll figure out the rest of it in a minute. And then this slope tells me at x equals 1, I have to have a also equally steep slope of 3. So I'm going to put a parallel slope of 3 through that point. So that's what I'm trying to indicate there is the tangent line to my curve. I have to have a curve that when it hits this point, the tangent line has to be looking like that. The rest of it is just a matter of making that happen. I don't know. Any ideas? That's some kind of x-cube graph. Maybe it comes back down like this.
Oh, that's clever.
That's not the only one possible, but one thing you don't want to do is like circle back on yourself so that it's not a function. I mean, those kind of things. Are we with this?
Could you make it piecewise, or is that too cheap?
Doesn't preclude it. I would encourage you to try to go away from that path, but sometimes piecewise is the only way to achieve it.
Okay.
In this case, I think I can do it fairly easily without the piecewise.
Great.
Okay, what about the other work where you had to draw graphs? Like they gave you the function graph, and you had to draw the derivative function graph. Or in the second part, they gave you the derivative function graph, and you had to draw the original function graph. That's 2 different things. And you got to be able to do both things.
Oh, crap.
I'll try these.
Can we do 29?
Love 29.
Which one?
29.
29. 29. Okay, so 29 is given as a function graph. Well, I guess this is number 29. What was that? That was 23. 29 is given as, what does it look like? Okay, it looks like that. This. There's 29. So this is f of x. I want to draw a picture that represents, I want to draw a picture of a function whose outputs represent the slopes at each point on this curve.
Mm-hmm.
Okay? So for example, it looks to me like that slope right there is not very big. So kind of shallow. So I'm gonna mark a point, a small point. I guess I need another graph. I'll do it on another graph so that we have that something. Over here, this is going to be F prime of X. I was going to do it on the same graph, but that was going to get messy, so I won't do that. Okay, so out here it looks like a pretty shallow tangent line. So that means the slope is small but positive. So I'm going to make a small but positive mark right there. Then I go right there, maybe say, looks like it's still a positive slope, but it's a little bit bigger. That might be 2 or 3 times as big. So maybe I got a slope about like that. Then when I get to about here, I really have a big slope. So I'm going to be up about maybe like that. But then what do you observe happens?
It gets smaller.
Well, first of all, go ahead. Swan dive. Before it goes negative, it goes 0. Right here, I have a horizontal tangent line. That means I've got to plot a point like that. And then over on this side, I've got a very steep negative tangent, so I'm down like this. And then it's not as steep. And then it's still not as steep, but still negative. So I get a picture of something like that. All that? Is that Chloe who asked us?
Yeah, I think so.
Is that Chloe who asked this question, or was it somebody else?
Yeah, it was me.
Does that help? Do you clarify?
Yeah, thank you.
Other ones. You're able to go the other direction.
Yeah.
Like in 31 through 34.
Can you do 33?
33. I'll go over here. 33. What's 33? 33, I got it. Come on, so it goes up through the origin, back up. Is that right for 33? The only difference is this is F prime of X. That's F prime. And we're asked to draw a picture of
It's so hard to visualize it. Okay.
well, now this is more challenging for most of us. So, how do I do this?
You want to do
Well,
the roots?
some key things here, folks. Thing number 1. That point right there, what does it tell me about my function? I have a 0 tangent line. Excellent. Does it tell me where the function graph is located? No. It just tells me there's a 0 tangent line. I don't know where the graph is actually located. In fact, we'll learn later, a little bit later in Calculus 1, that there's a whole family of curves that will satisfy this. So that comes later. So for now, since I don't know where it's going to be located, I'm going to allow horizontal tangent lines at that location anywhere. So here's how I'm going to do that. This location right here, I'm going to say it could have a horizontal tangent there, or maybe there, or maybe there. I don't know. Somewhere it's got to have a horizontal tangent. Now follow me? You're exactly right. F prime tells me the tangent line has a horizontal, is horizontal with 0 slope at this point. I don't know where the function is physically located. I'm allowing it to be anywhere. Call this a slope. Yeah, that's called a slope. That comes back very soon. Mark that in your notes. What about this one right here? What does that tell you? Same thing. Once again, I know where the function is going to be located. No, so I'm gonna allow it to be anywhere. I'm gonna put some horizontal tangent lines all the way down here, creating what's called a slope field. One more time, I got one right there. So I'll do the same thing out here. Now, to really make it work, we've got to have more information than that. Those are the critical values. Get that first order critical values. When the velocity is 0, those are called first order critical values. That's what we just looked at. So those are my first order critical values. But what's happening in between those? What do you know? Like, what does this tell me right here? To the left is that first order critical value. The slope is negative.
Yeah.
Being more negative the further left you go. So I'm going to put some negative slope field in here.
So it starts out really steep.
Starts off very steeply. And the further left you go, the steeper it gets.
Yeah.
Okay? In between these two first order critical points, what does this velocity function, also called f prime, tell you? It's positive slope.
Yeah.
That means it's expansion. So we're going to have some positive slope in here. And in between these two, I've got some negative slope. That's all negative stuff. So that's telling me the slope is negative. So I'm going to put some negatives in.
I love it. Continue.
Outside of this first order critical value, it's always positive. So I'm going to put some positive slope. And as we observe, the further out you go, the more positive it gets. So I'll put some even more positive slopes on. All you got to do is do it.
The W.
Yes. You get a sense of the flow from the slope field. That's actually a thing you do when we go forward up in mathematics. You actually get a sense of things rather than just the exact answer always. And pick a point. Anywhere you want to pick a point. Meaning, how about right there? And now make the slopes match. So that's going to have that slope, and it's going to have that slope, and it's going to have that slope, and it's going to have that slope, it's going to have that slope, and then that slope, and then that slope, and then that slope.
Wow.
There we go. Is that the only answer I could have drawn? Could have picked a different starting point. Hoping it's good. Okay. So, whoa. All right. So, what we're going to do is, as you head out, I'm going to hand you a homework assignment. You have another lab that I'm going to hand you to do over the weekend.
That's over the weekend.
So, read section 2.2 and do problem 1. We'll talk about it more on Monday. But at least read section 2.2 and try problem 1. Ms. Langer, if you hand out that other lab that I sent you on introduction to derivatives, pick 2 on Monday and 2 on Monday. Now this, hopefully when you do this lab, this is going to look very familiar. It's like we're doing it one more time again. That's good because we need to practice. So hopefully this will be very good. Have a good weekend. Get out there.
Guys, I think the one lab we need to focus on
Maybe it'll be
is the heat lab, because that's the one we did the worst of. Even though we didn't do that. Yeah, that was our lowest grade. It was like the food stuff that screwed us over. You know what I'm saying? It was the food stuff that screwed us over. I'm predicting he's going to give us another food one. It's carbohydrates is 4, fats is 3, proteins is 4, right? 4.
Yes.
Yeah.
Let's take a short break. Go back from break, rest, eating session.
Rest eating session? Is that what you said?
Before we hang up, I want to find out, y'all, I want to find out why other counties like
Elise, are you going to the competition?
I'll try to show them.
It's on Saturday.
I work on Saturday.
Why can't we steer? You know, it's a different class, still it's the same class.
You just.
Sure.
As long
Full bench? Well, we have 8 here.
and then what we would do is, instead of doing
Dylan.
so we're the ICC students, we
I know. So you guys, we have
everything, they won't see your grades, but they'll see the videos you're taking of students, and they will
I mean, I'll find a way to make it work if you
not
want.
see the students' grades, but they'll be.
I'd like to talk about it.
Amanda?
Saturday, November. Yes.
Before you leave, I wanted to ask you a question. I talked to, you know, on the phone or something in 2 minutes, but I just wondered if I can talk to you for a minute sometime. Go ahead and finish with your story.
Yeah, just give me a call in about 5 or 10 minutes. 5 minutes.
Okay.
Okay. So you want to talk about it? So we have math club next Friday. No, we're gonna do it the first Friday of the month. And then if you guys want to meet more often, then we can meet more often. But I'm gonna meet math club first Fridays.
Okay.
And this next Friday, we are gonna be helping with the 8th graders that are coming.
Sorry, I gotta print out the volunteer thing. Do we have to do that and turn it into and do everything and?
Well, that's different.
That's different.
Yeah, the 8th graders are coming here for a tour. What? So I thought we would have math club out and visible for them to see us. So we'll put up our little poster board that says math club, and then we will do better chalk drawings than we're out right now. Okay, cool. That is next Friday.
Okay, I thought you said tomorrow, and I was like.
Do we still have the old posters from last year? Let's see. Let's put them back up.
Yeah, and so we'll just be out mathing outside while the 8th graders walk around.
Are some wearing joggers?
So we could talk about stuff then, but we are also gonna talk about designs for our t-shirts.
Okay.
Yeah, I made a lot of drafts.
So we need some designs, so bring like paper designs that you would like on this t-shirt, and we'll try to get Emily to iron them on for us.
It's an origami shirt.
And I'll pay for the, whatever, the iron-on stuff.
Carson, what's in that room?
So you guys have homework, we need designs. Okay, and I'll go ahead and get everybody registered, and I think we can switch out people if we need to,
He's in here.
but we're all paid for.
You ever heard that weird echo coming through the walls?
And the guys, what are their names?
I don't know. Every North Carolinian ever, rabbi.
Keep